Welcome back. So today what we're going to do is we're going to talk about the other type of elimination that I mentioned in the last lesson. So this one is using a little bit of multiplication to help us use elimination, right? So let's kind of recap the methods that we've talked about so far. We've talked about substitution, and substitution works best in these cases, right? When you have two slope-intercept equations, which are your regular old y equals mx plus b. Right, so if you've got two that look like that, use substitution. If you've got one slope-intercept equation and one standard form equation, then you'll also want to use substitution, right? Both cases, substitution is going to be the easier one for you, right? When we're talking about elimination, that's going to work best when you have two standard form equations, like we mentioned last time. Right. And again, if you don't quite remember what standard form is, right, those are the ones where all their x's and y's are all together. It sort of looks like ax plus by equals c, right? Might not always be x's and y's, right, as we saw towards the end of the last one where we were talking about n's and m's and the word problem there, right? But if you have two standard form equations where all their variables are smushed together on one side, elimination is going to be your best bet, right? So we've got our steps here, right, and most of them are filled in for you if you've got one of the sets of notes I handed out during class, right? They're pretty darn similar, and actually they're exactly the same as what we were doing last time, except now we're going to be filling in this piece, right? So when we're starting these problems, we're going to look at the coefficients and say, are any of them opposites? If yes, we add them. If not, we look again and check if any are the same. If yes, we subtract the equations, right? So that's all stuff we talked about last time. If the coefficients are not opposites and none of them are the same either, right, then we have this step here. Right, we're going to write a little bit in here. If the answer is no, you're going to have to multiply one or maybe even both equations to make them have similar coefficients. All right, so, again, if you need to pause here to finish writing, that's okay. So what we're going to do, right, is if none of the coefficients match up, right, if none of them are opposites, none of them are the same, we're going to need to multiply one or possibly even both equations in order to make them have similar coefficients, right? So again, it's just that first step in this solving process that's changing a little bit, right? After that, we solve for the variable, we plug it back in, we solve for the second variable, right? Everything after that is just as we've come to know it in the past, right? So let's take a look. First problem on the back here, right? We want to solve this by elimination. So again, first things first is I'm going to look at the coefficients, right? I got a 5 and a 3 for the x's. I got a 4 and a negative 9 for the y's. So none of those match up, right? So the 5 and the 3 don't match, the 4 and the 9 don't match. Oy. So what we're going to have to do is we're going to have to multiply it to make them have similar coefficients, right? So a couple things here. You know, you're welcome to do whichever one you want, right? But choosing the ones where the numbers are maybe a little smaller, right? Like I'm going to choose to work with the x's might be a little bit easier than the other ones, right? It depends. So what I'm going to do is I have 5x and I have 3x. I want to come up with a way to make them have similar coefficients for those x's. Right, so what we're going to do is we're going to multiply both the top one and the bottom one by just some number in order to make those numbers the same. Right, so think about what you could turn 5 and 3 into. Right? And if you're thinking 15, right, just 5 times 3, right, then you're all set, right? So in order to turn 5 into 15 up top, we're going to multiply everything in that one by 3. To turn 3 into 15 on the bottom, we're going to multiply all of that by 5. All right, so let's take a look at what that's going to do. So for the top one there, we're multiplying everything by 3. So that 5x is now going to be 15x. We're going to have 4y times 3 is now 12y. All right, and then over on the other side, negative 30 times 3 is negative 90. All right, so we've got 15 for our x there. That's what we were hoping for. Let's go ahead and do the second one. Same deal. We're going to get 15x. We're going to get negative 45y when we do that multiplication. And then on the other side, we're going to get negative 90. All right. So what we've got here, right, is now this is our new and improved system. It does have coefficients that are similar, right? These 15s match up. Because those 15s are the exact same number, right, we're going to be subtracting them. All right, so let's go ahead and do that. All right, so when we're doing the subtraction again, I like to use this method with the parentheses. If you like to go and change all the individual symbols, that's also fine. So what I'm going to do, 15x minus 15x, the x's are gone. We've eliminated those. When we do 12y minus negative 45y, remember that that's going to kind of work like addition. We're going to end up with 57y there. And then last but not least, negative 90 minus negative 90, right? So again, it's going to work like a plus sign there. We're actually going to end up with 0, right? Negative 90 plus 90, right? When you get to here, don't freak out. 0 is a number, right? You can get 0, right? Not the end of the world. After that, we just got to figure out what y is. We're going to divide by 57 to get rid of that. All right? And when we divide 0 by 57, it's still just 0. Right? If I have 0 things and I split them into 57 equal piles, there's still 0 in each pile. All right? So y is 0. Right? After that, we still need to plug it into one of our original equations. Right? So you're welcome to use all this space over here for that. Just to kind of keep things on the screen, I'm going to do it out underneath over here. Right? So I'm plugging in that y equals 0. I can choose whichever one I want to plug it back into. I'm going to choose the bottom one because the numbers are a little smaller. Right? So we've got 3x minus 9y, right? So 9 times that 0 equals negative 18. Right? And again, just like before, we're just doing a little bit of simplifying. It's going to be 3x minus 0 when we multiply equals negative 18. And then it's like that 0 isn't even there, right? We can just kind of ignore it. Right? So it's kind of like we've just got 3x equals negative 18. When I divide both sides by 3, that's going to get me the x that I'm looking for, right? And x is going to be negative 6. All right? And that's it, right? So again, just that first step is what changed, right? After we figured out, well, like where we were going, we got to 57y equals 0 right over here, right? After that, it's just solving it out, plugging it back in, solving for the second one, right? Just that first step that's different, right? Let's try it another one. So, same old deal, right? I'm looking at my coefficients, 3 and 6. Looking at these ones, negative 4 and negative 5, and none of them match. So that kind of sucks. So what we're going to need to do is we need to multiply, just like before. On this one, we might be able to get away with multiplying just one of them, right? If I'm looking at the x's, if I'm thinking about getting 3 and 6 to be the same number, well, I could just turn 3 into 6, right? I could also like turn them both into 12 or something like that, right? But if I can just turn 3 into 6, that's less work that I have to do, right? So to turn 3 into 6, we're going to multiply just the top one, all right? And you might be thinking like, oh yeah, let's multiply by 2. So I'm going to do something a little bit weird, so bear with me. I'm going to multiply everything by negative 2, all right? When I do that, let's take a look at what's going to happen. 3 times negative 2 is negative 6x. Negative 4y times negative 2 is plus 8y. Right? And then 7 times negative 2 is negative 14. Right? So that part's all done. This one we didn't multiply, so I'm just going to drag it right over. We've got 6x minus 5y equals 20 over there. Right? So I don't know if you can spot it yet, but the reason why I might want to multiply by negative 2 there, right? It's because now if I'm looking at those coefficients for x, we've got a negative 6 and a positive 6, right? When we've got them as opposites, right, now I don't need to worry about subtracting them. I'm just going to be adding these equations together, right? And the adding, I don't know if you'd agree, is a little bit easier than doing the subtracting, right? Because, you know, we had to, on this one, we had to subtract, and we had to say, like, oh, yeah, this subtraction works like addition here because it's two subtractions, right? And this one, now I don't have to worry about that. I can just add them together. All right, so let's go ahead and do that. We've got negative 6x plus 6x. Boom, they're gone. Right? 8y plus a negative 5y. Right? It's going to work like regular old subtraction here. We're going to get 3y's. And over on the other side, negative 14 plus 20 brings us to positive 6. Solve for y by dividing by 3, and we're going to find out that y is equal to 2. All right? And then we're halfway there. Right? We still got to plug it back in. You know, again, whichever one you want is fine. I'm going to plug it into the first one because it's smaller numbers. We got 3x minus 4 times that y we just found equals 7. I'm going to go ahead and simplify. 4 times 2 is 8. I got to move that 8 to the other side to get it away from the x's. And then last but not least, to get that x by itself, we got to divide by 3. All right, so what we're going to find is that x is equal to 5. Cool, and that's it. That's all we got to do. All right. So, again, these are definitely a little bit more complex than the ones we were talking about last lesson, right? Because there is that added bit at the beginning with the multiplying. But what I'd like you to do is try out number 3. Right? If you want to pause here and leave this one on the screen as an example, that's not a bad idea, right? But try number 3 out, see what you get. See if you can at least get through the first little bit. Solve for one of the variables. All right, so hopefully you paused and tried that. If not, give it a go, right? It's not, the worst that could happen is you're wrong, and that's not that bad. So for number 3 down here, I'm looking at my coefficients, and again, none of them match, right? 2 and 6 don't work. Negative 3 and negative 2 don't match, right? So we got to multiply. When I'm looking at, you know, for in this case, the x's, same thing as the last one, right? I think we can just turn 2 into 6 and only have to multiply one of these. Right? Again, if you wanted to multiply both of them and turn them both into 12 or something, that does work. You're just making more work for yourself, right? So what I'm going to do here is, again, I'm going to do that little weird thing. I'm going to think ahead a little bit. I'm going to multiply by negative 3, right? For a reason similar to the one up top there. So 2 times negative 3 is negative 6x. We're going to get plus 9y, and then equals positive 3. The one on the bottom already has a 6 for the x, so I'm just going to drag it right over. 6x minus 2y equals negative 24. All right, so again, that little bit of thinking ahead now means that all I need to do is just add these together, right? If you went ahead and you ended up needing to subtract these from one another, that's okay, right? It doesn't mean you're wrong. Let's keep working through it and see if we end up in the same place. So what I've got is those x's are going to cancel each other out, right? Negative 6 plus 6, boom, they're gone. For the y's, we got 9y plus negative 2y's, which will bring us down to 7y's. And then 3 plus negative 24, right? So 3 minus 24 brings us to negative 21. Got to divide by that 7 to get rid of it. We're going to get that y is equal to negative 3 on this one. All right. And again, got to plug it back in. You have all that space to the right, so if you want to do it over there, that's perfectly fine. Again, I'm just trying to keep everything on the screen at the same time. Right, so I'm going to plug it into that first one because the numbers are smaller. We got 2x minus 3 times that y we just found, which was negative 3. Then just doing a little bit of simplifying, right? 2x plus 9 equals negative 1. We got to move that 9 away from the x's, so we're going to push that to the other side. Get that 2x equals negative 10. I got to divide everything by 2 to get that x all by itself, which is negative 5. All right? And before we know it, we're already done with it. All right? Not too bad. All right? We got 2 more problems we're going to talk through real quick, and then I'll let you go. So for this one, right, same deal. Coefficients don't match. We're going to need to multiply. As I'm looking at those coefficients, right, the negative 3 and the 4, and then the 2 and the 5, there isn't really a great thing that we can just like multiply one of them to get the other. So I'm going to end up needing to multiply both of these equations. So then we got a choice, right? We could either work with the m's or the n's. All right. And you might be thinking like, oh yeah, the n's look pretty easy, right? 2 and 5, you can turn them into 10 and whatever else, right? But what I'm noticing is that on the m's, we already have one that's negative and one that's positive, right? When I multiply and get them to be similar, right, I'm already going to be able to add those equations together and, save myself a little bit of headache, like we've been talking about a little bit. So what I'm going to do is I'm going to turn those m's into 12, right? So to do that, I'm going to multiply the top one by 4, right, to turn 3 into 12. To turn the bottom one into 12, I need to do 4 times 3. All right, so let's go ahead, let's do that multiplication. All right, we're going to get negative 12m plus 8n equals 24. When we multiply on the bottom, similar, we're going to get 12m plus 15n equals negative 93. All right, so again, because those m's have opposite coefficients, I can just add these together, right? Save myself a little bit of headache. So those m's are going to cancel, right? Which is what we were hoping for, right? That's what we were focused on. As far as the n's go, right? 8 plus 15 will give us 23 n's. And then last but not least, those numbers, 24 plus negative 93 is going to give us negative 69, right? After that, we got to get rid of that 23 so we can get n all by itself. That's going to tell me that n is equal to negative 3. Right? And again, after that, same old boring thing. We're going to plug it back in, right? I'm going to plug it into the first one because the numbers are smaller. We got negative 3m plus 2 n's, right? We just found out that was negative 3 equals 6. I'm going to simplify a little bit. I'm doing that multiplication now. I need to move that 6 away from the m's. I'm going to get that negative 3m is equal to 12. We got to divide by negative 3 on both sides to get that m all by itself, which comes out as negative 4. Right? So again, as you notice, and I know that I'm going a little fast on some of these, but it's because I'm hoping that this last part, like actually everything I'm about to highlight right here, hoping that all of this seems pretty okay, right? It's the same old thing that we've been doing on the last 3 or 4 lessons. It's just that first step that is different to us, right? So if you're feeling up to the challenge, what I'd like you to do is, again, challenge you to try out number 5, right? There's a couple different ways you can get the coefficients to work out, right? So again, if you're try it out on your own, if your way doesn't look exactly like mine does as I'm working through it, that's okay, right? As long as we end up with the same answers in the end, then it probably means you must have done something right, All right, so pause here, try out number 5. Hopefully give that a go. Let's take a look. So, number 5, coefficients don't match up. We're going to need to multiply. If I'm looking at them, 6 and 4, 5 and negative 7, I can't just multiply one of them to get to the other number. I'm going to have to multiply both equations, right? So, what I'm thinking is you could have chosen to work with the m's, you could have chosen to work with the n's, right? Either one is fine. I'm going to choose to work with the n's, right? Because again, oops, let's make that a little smaller again. Just like on the last one, we have a positive and a negative. They're already kind of built into this one, right? So if I make those similar, I'm just going to be able to add the equations together. All right, so let's do that out. In order to turn these n's into the same number, I'm going to need to first choose a number, right? I'm going to choose 35, right? I can turn 5 and 7 into 35 each. So to go from 5 to 35, I need to multiply by 7. To go from 7 to 35, I need to multiply by 5, So up top, we're going to multiply everything by 7. It's going to be 42m. Actually, I'm going to scooch this over just a wee bit. Plus 35n equals, what's 38 times 7 going to be? Let's find out. 38 times 7 is going to be 266. All right, we're going to do this out for the second one there as well. 4 times 5 is going to give us 20m. Right, we're going to end up with negative 35n, which is what we were hoping for. And then negative 16 times 5, I think I know, but I'm going to double check just to, be absolutely sure that we don't mess up this problem. Negative 80. Right, so now we've got these similar coefficients, right, the n's. Because they are opposites, I'm going to be able to just add these together. Right, so for the m's, 42 plus 20 gives me 62 m's. The n's are gone, right? We canceled those out. And then over on the other side, 266 plus negative 80, right? And if you have a calculator, 266 plus negative 80, you can just plug it in right like that. Gives us 186. All right? To get that m by itself, we need to divide both sides by 62. Right, which again, I would suggest using a calculator for if you're feeling a little unsure. Think that m is going to come out as 3. Right, so again, yours might look different than mine. Right, we might have chosen to turn different coefficients to be similar and all that. We might have even chosen different numbers to use to get them similar. Right, if you ended up with m equals 3 at this point, or at some point during your problem, then you're probably on the right track. Right? I'm going to plug this back in. I'm going to choose the first one because the numbers are all positive. Let's do that. So 6 times that m we just found plus 5n equals 38 for that one. And again, just doing some simplifying. 18 plus 5n equals 38. I got to move that 18 over to the other side. Get it away from the variables. We get that 5n equals 20. We'll divide both sides by 5, and oh my goodness, the end is in sight. N is equal to 4. Right. So again, if you ended up with n equals 4 and m equals 3, awesome job, right? These problems are not particularly easy, right? If you're able to get through these, especially trying them on your own, that's awesome, right? So that's the end of this one. I'm going to let you guys go. So if you have questions, be sure to ask, right? That's what we're here for, is to help, right? So as for now, I'll see you later. Bye.